Well, my name is Vekослав Stefановski. You can always reach me at Svekster on Twitter. You can see what I've done at Svek on GitHub. So far, I don't have an OnlyFans, for now. What I mostly do, I'm head of development in Sorsico, Macedonia, and I've been coding professionally for 2 millennia right now. I love programming and I love programmers. So I've been almost a quarter of a century in this business, and it's fun so far. I don't know if it will get boring later on, but so far so good. I have a long and fruitful love relationship with all kinds of servers, starting from Windows servers, Linux servers, SQL servers, all kinds of things like that. But around 10-ish years ago, this new thing came along that is called somebody else's server, or cloud as we call it. And I have a long and fruitful, in Facebook terms, it's complicated relationship with cloud. Sometimes I love them, sometimes I hate them, and they usually hate me. I'm relatively lazy, so there won't be too many slides. I will try to show as much as I can. Thanks to all of our sponsors, you can see them in front, you can get the goodies, I know I did. And without them, this wouldn't have been possible to have such a fun day. So what I will be talking about today. First, I will be doing a bit of a crash course on what authentication is and why do we need it and what happened so far and so on. I will give a brief overview of OIDC. Then, I don't plan to rant about Json Web Tokens, but I will. It's kind of inevitable that when I get to a certain point, I tend to do that, so why not put it in the agenda? I will talk about having passwords on the cloud specifically. Most of what I'm going to be talking about applies to all the cloud providers identically, whether that's Microsoft, Google, or Amazon, or FusionOut, OutZero, Okta, what have you. All of them basically have the same offering and suffer from more or less the same problems. But I will be focusing on Amazon AWS Cognate in the later part of the talk, because that's what I am using right now, and I will describe what is my authentication stack at the moment. So, how do we get to this point of space and time, authentication-wise? First of all, one thing that totally and always annoys me. When we say out, what do we mean by out? Recently, people started using the out-N term for authentication and out-Z for authorization. And everybody got mixed up. Even I will oftentimes say authorization when I mean authentication. Basically, authentication answers a single, simple question. Who are you? That's all it does. It does not go after that. And authorization answers the much more complicated question, what can you do? What with it? So those are two interconnected things. They are definitely separate. Because authentication-wise, in the real life, let's make a real-life parallel. What do you do? What do you use as an authentication provider? If somebody comes up to you and say, my name is Boyko Borisov, how do you determine that that person is indeed Boyko Borisov? You ask for an ID card. You ask for an externally provided authentication document. So we do have an authentication authority in real life. It's usually the Ministry of Interior or something like that. We are using that, and we have that federated, so to say, because they are the only guys that are allowed to issue authentication documents, and they are the only guys that are actually authenticating us. And regarding authorization, we have about a zillion things. I guess wherever you're working, you have those cards that say this guy can go here but cannot go there, and so on and so forth. And there are much more rules and much more complicated things. But authentication-wise, we only have a single federated authority that basically we all use per state. In Macedonia we have ours, in Bulgaria you have your own. And of course, what is the problem then with the authentication? Well, the problem is if somebody manages to provide us with a wrong answer to that question. Nobody will try to basically forge an employee card, because that's not forging. You just go ahead and print one if you want to. It's not such big an issue. But if you want to forge an ID card, then you need somebody who's professional at that. In real life we call them hackers, on the internet we call them hackers, in real life we call them forgers. But that's the exact same thing. They're trying to hack the authentication protocol we are using in order to represent themselves as somebody else. So, after that small rant, and an unrelated rant, I hate that HTTP status 401 is usually called unauthorized. Because it's not. It definitely means I have no idea who you are. That means you are not authenticated. The question of authorization doesn't even arise. I cannot say whether you are allowed inside Beer.js if I have no idea who you are. You might be, you might not be. Then we have the 403, which is actually unauthorized, but of course we're going to call it forbidden. Why? Because life is fun. Yeah, the same development, it makes everything easier if you go crazy early. So, the internet started, the web started somewhere around in the late 90s, and first we had a bunch of sites where we had lyrics from Nick Cave and things like that, and nobody needed any passwords and nobody used any passwords and everything was fine. And after that we wanted to have customizable things, like maybe email on the internet. Who knew? So we started using users, and we stumbled on the stupidest way, but it's the easiest way to use, and we managed to enforce that everywhere. So that's, you write a username, and then you write a secret that only you know. And it's usually PSSW or RD. And so from the user's perspective, this is one kind of talk, because after that people said, no, you have to use large and small numbers, capital and small numbers, and we used capital P password. Then you said you need to add a number, and when we said, of course, password 1, no, you need a special character, and of course it's password 1 exclamation mark. Who here has a password 1 exclamation mark password somewhere? Yeah. We collectively decided that the correct password is password 1 exclamation mark. People are going to say don't use that, but everybody will use that. That's why I'm saying username and password is one of the worst mechanisms, but that's what we have. But on the server side, we need to store that password somewhere. And of course, initially, where do we store it? Well, in a database, in plain text. Who's going to look in there? Who's going to use that? And of course, people started using that. And then we said, oh, we're going to encrypt it somehow. Everybody in this room who's older than 40-ish, in the 90s implemented their own encryption algorithm. I know I did. So the user cannot read the password from the password field in the database. Yeah, sure. And after that, some hacks happened. Hacks in the mean they got the database and they said, oh, this is row 13. We have the passwords now. So we said we're going to use a custom salt and make it a one-way hash function and do this and do that. And then basically the topic of this presentation happened, the cloud came in. And with the cloud, we can take the OPP approach to password management. Anybody knows what OPP stands for? Others people problem. Yeah, the simplest way for my passwords not to be stolen is that I don't have them. In the same sense that the simplest way not to get ovarian cancer is not to have ovaries. No matter what I do, I cannot get ovarian cancer. So that exact approach applied to passwords is the OPP approach when somebody else will store our passwords for us. Something like this. Actually, no, something like this. I mixed up my slides. So, you don't need to secure your passwords. You store them somebody in the cloud, and then you trust that cloud. To be honest, this sounds like what happens when that cloud gets hacked. Honestly, if Amazon gets hacked enough that somebody stole all the Cognate passwords, the world is screwed, not only us. So until they get to us, yeah, it is a real problem, but to be honest, I also have more confidence that Amazon's engineers are able to prevent a Cognate data leak, that I am capable of preventing my own data leak, that I don't have somewhere a URL that accesses the database directly and whatnot. There are people whose job is literally making that thing secure. And so far they manage, and I'm going to trust them. Just in the same sense that I don't keep my money, what little of it I have, at home, inside my mattress. I keep them in a professional institution. A bank can get robbed, but far less likely than that I will be robbed and somebody will just take my mattress. The money in my mattress, they don't really need my mattress. And also, when we're using a service that provides this, we are divesting ourselves of our problem, but we're also getting the best practices. Because again, those people are password management and security management professionals. So they know what to do. That's the idea at all. And of course, if we have our own solution, we need to take care of a lot of extensibility points that are getting more and more popular. Things like multi-factor authentication, things like single sign-on, with or without OIDC, and of course using OIDC, using SAML, using federated identity providers. And what does that OpenID Connect or OIDC actually mean? It means that we can also, of course, our users are going to be stored in a single place because we need our users. Our users have a profile that is relevant to our application. But that is more on the authorization part of things. But regarding the authentication, that we can confirm that those users are actually those users, we can even outsource that even more. Not only having our passwords stored, our users stored in the cloud, but having those users confirmed by a third or fourth party, like Facebook, like Google, like their employer. So we can use somebody else to authenticate the user, somebody we trust, and somebody that even our cloud provider trusts. So after they confirm that that user is who they say it is, then we can trust that that user is really that. That means that we're going to contact some bigger site, as they say here, an identity provider that we trust, and we will ask the identity provider to verify a user. After the identity provider verifies the user, it returns the data back to us. We are the service provider, and we can provide the service knowing that that user was checked by somebody we trust. This means that if we have some identity provider that is terribly useful, because one thing that people don't want to do, and me included, is to create new accounts for new sites, and a new email, new password, new everything, new whatnot. So what we can do using this is the sign in with Facebook, sign in with Google, sign in with Microsoft, sign in with Yahoo, sign in with whatnot functionality. That we are able to use, the site is able to actually use Microsoft, whom it trusts, to verify that Veco is Veco, and then Microsoft says, yeah, I verified Veco, and the SaaS says, okay, if somebody screwed up, Microsoft screwed up. My site didn't do anything. I asked Microsoft, is this Veco? Microsoft said, yes it is. If Microsoft is lying, so am I. Of course, that provides for a better user experience, but that means that we have even more privacy concerns, because then Facebook or Microsoft knows that I'm using that site or that site and knows how I'm using it, when I did login, and all of that. But to be honest, privacy is mostly that anyway. I think there are at least a dozen companies that at this moment are aware that all of us are sitting in the same large hall and talking about this. And depending how granular the data is, they might even know that actually I'm 10 feet in front of everyone, so I'm giving a lecture. And how does it do this? It does it by using a lot of Json Web Tokens. Has anybody seen a Json Web Token? Ooh, everybody. Cool. This means that you're my target audience. I love Json Web Tokens. But what I hate is the way that some or most developers use them. They treat Json Web Tokens as basically magical things. That once I get a Json Web Token, I have this magical thing and everything works with it. No. Json Web Tokens are a very, very simple concept. Let's see if I have my application. So I will be showing this actually in a production application that is not running. So most of my demos won't work because on a Saturday we are shutting down the staging, so because nobody works, but I forgot that part. Come on, work. Oh, again, staging is out. I'm going to need my glasses because I think I messed up the dots. So, yeah. Oh, you don't see my screen? How about now? Yeah, that's one of the beauties of PowerPoint. When you're doing PowerPoint, you don't really get to see anything else. Yeah, no need to zoom in. I will. Yeah, this is a Json Web Token. You've seen this, and this kind of looks magical. What is this? This is just random string. No, this is a completely simple process. This thing has three parts. It has a header, which explains what it actually contains in the other two parts. It has a payload part and some third part that nobody knows about. That's the usual perspective that most developers take, that it has a first part that's everything up to the first dot that you can safely ignore. It has a second part that you can do some call and it will give you some data. And then it has a third part that nobody knows what it does. And there is this site. That can tell you a lot of data, that can basically extract all the data from the token. And the header says, this is basically the ID of the key and the algorithm used to generate it. And this is the data it has. And first of all, one thing, this is a so-called access token. One thing that annoys me very much is that most identity providers and most implementations have at least 3 different types of tokens. The ID token, the access token, and the refresh token. Let's ignore the refresh token for now. The ID and the access tokens are basically Json Web Tokens. Straightforward up Json Web Tokens. And nobody has any idea how they should be used and what should be inside each one. So I've seen everything. In essence, the ID token only contains the profile of the user, only contains the user data, only contains the user claims. And it can be used as an entry point into the authorization system. And it should not be used on the front end in general. The front end has no need of the ID token. And that is a hill that I'm ready to die on. The front end might need some user data, but we have some kind of a backend service or something like that, or a Lambda or what have you, that can provide that data. Maybe based on the ID token, maybe not, who cares? But the front end does not need the ID token itself, because the ID token definitely contains enough personally identifiable information. If the ID token is stolen, basically you will leak data about a specific customer that might not be obvious, that might be sensitive. So the best way for the ID token not to get stolen from the front end or in transit is to not make that transit. If you don't have it on the front end, nobody can steal it from the front end. The access token on the other side is still sensitive, and it's extremely bad thing if it gets stolen. But the access token only serves as a token. It doesn't have any inherent meaning on its own. So, yeah, a talented guy can infer some PII from that, but in principle it contains way less user data than the access token. This is the real access token from my system, and you can see that, yes, it has a lot of data here. You can definitely see that my system is using Cognate. You can even see which pool I am using. I will talk about that a bit later. And you can see the username, which is a good. So there is data here, but you don't know my first name, my last name, my home address, my phone number. You didn't get that data. You might use that GUID to somehow extract them from somewhere, but that's a second order problem. And if we manage to stop it there, still better than nothing. We don't want the access token to be stolen. But in theory, it could be. If we are sending it outside of our machine, it can be stolen. It's out there in the wild. One attack that nobody can defend against is basically Chrome extensions. That's more or less the user actually giving the access token to somebody. Or a person might trick somebody to paste the access token in a chat. And you cannot, there is just no way to enforce not doing that. You can tell the users don't do that, but they will still will. Still, with only an access token that expires very soon, the best expiry time for an access token is something like a minute or 5 minutes. Even if they paste it to an attacker and an attacker gets it, they might get the user ID, but they won't be able to abuse the system. So that's the good thing about, that's the difference between access tokens. And another thing, especially on the front end, is how people are storing the access token they have, the tokens they have. Because more often than not, you will see the ID token here as well. They are using local storage. And local storage, by default, is basically accessible to just about anybody. There are a lot of rules who can access it, but in principle, everybody can. I'm storing it into a cookie, and moreover, I'm storing it into an HTTP-only cookie. So the only person who knows about this cookie is Chrome. And I'm going to have to trust the browser. As I said, there's a line that basically has to be there somewhere, because the cookie has to be there. But you see that I have these 4 cookies here, and if I say to a console, ignore the red parts, give me the cookie, it will say, oh, well, you have a last visited page cookie, you have an end user data cookie, you have an active account cookie, and that's about it. Where's my access token? So if somebody is able to inject JavaScript into my page, which is quite a common thing, they cannot steal this cookie because they cannot see this cookie. They cannot get my access token. They will have to use something like a browser extension or a stupid user. Those are in abundance, but this won't work at least. No, the system is always as secure as your least secure component, and that's a given, and that's not going to change. Okay, that's about securing the token itself. But a lot of developers I've seen are not even aware what is inside the cookie, the token. Because this is actually not magic. This is regular text. This is regular text. This is a JSON object. It just doesn't look like a JSON object. So if I don't use this site, if I use this site that basically decodes a base64 string, and we can do this by hand if we want to. If I paste this and decode it, guess what it will be decoded to? It decodes to this text. This is plain text. JSON Web Tokens are plain text. They are not encrypted, they are just encoded. This is plain text. The header and the payload of any JSON Web Token is plain text. And that means that anybody can edit that plain text. If I want to change this token, let's say I want to change this E to an F. I just need to change it here to encode. Paste this text, encode. I don't need the equals sign. And now I have a different token. Can you notice the difference? Of course not. But what happens now when I paste it here? Yes, you can see this thing here, I think it was an E, I changed it to an F, right? Doesn't matter, now it's an F. So I could basically change all of this. Is this a valid JSON Web Token right now? Depending on the application. Now let's go back to the third part of the JSON Web Token. That's the signature. That is actually the encrypted part. Because the server that is issuing your JSON Web Token will do some kind of checks and magic and everything, and it will have an encrypted part. But verifying the JSON Web Token is a non-zero operation. It does not happen on its own. If you don't verify it, it will not be verified. And usually that involves taking the key from some well-known location, comparing it, doing some math. There are ready-made libraries for that, but they don't use themselves. You will have to explicitly say, yes, I want to verify this token. So here I have my part of my code that is actually verifying the access token. And it's on me to actually verify that the signature is correct. And in more situations than I can count, I have seen this step omitted. Because it's usually asynchronous, and when you have to have a synchronous checking, or the developer just didn't know or just didn't care. In lots and lots of places, I just saw something like, okay, here I have it. Yeah, something like this. Split the token on the dot, take the middle part, convert it to a JSON, everything's shiny. On that system, on those real systems that are in production right now, maybe in your bank, my change will work. I would have validly changed that D into an F. Or I could have validly impersonated another user who was able to get that user ID. Or I might have been able to extend the session. So I borrowed the computer to somebody and they just use their bank and they think they will be logged out after 5 minutes on inactivity. But I said, this thing lasts a day. I can come in tomorrow and do what I want. Because the signature will not be checked. It's really easy to check the signature. I have it somewhere. Yeah, we're getting the keys, decoding something. I guess we have that. Somewhere around here. Yeah. A lot of this is hidden in extra functions and whatnot, but this is the process that will verify the access token in depth. And we actually have this, this process takes some time. It's not a trivial process. And it needs to happen on each and every request, because on each and every request we are getting that access token from our side. So we need to verify it each and every time. And that needs to be happen extra fast, and we want it to be extra safe. And those are kind of clashing. What we do specifically on our side is this method is very much cached and very much optimized, so to say, so it doesn't incur performance penalty. But I've seen things, places where the performance is gained by not verifying the access token. That gives you performance, but let's not talk about what you lose. As I said, I love Json Web Tokens. Oh. but I don't really love how developers are oftentimes using them. If you already knew this, if you're already doing this, then sure, I wasted your 15 minutes of your life. But if this didn't click with you, that not verifying the signature is basically allowing everybody and his mother in, I hope that this talk will help somewhat. So, there are different kinds of JSON Web Tokens, and you need to use them for the different use cases. And you need to do three things, basically, with each JSON Web Token. That's verify, verify, and verify. If you're not sure if anything looks suspicious, and that's valid for all of the authentication. If anything at all looks suspicious, at the first sign of suspicious activity, shut everything down. Yeah, that means that if any part of the user verification is not ideal, then it's a 401. Sorry, I don't know who you are. Because if you reject valid users, that's not ideal. But if you allow invalid users, that is catastrophic. So the disbalance of error is obvious on one side. Prefer not to allow valid users. And then, of course, you will have some guys from customer success deal with that, and it will get to you after a week that somebody cannot log in. That happens, I'm not gonna lie. This is a real life system with real users, that happens. But it's much better to disallow somebody who is valid than to allow somebody who is invalid. And all of this, as I said, uses a specific identity provider called Cognate. That's Amazon's version of authentication providers. It has a concept called user pools. It keeps the users in separate user pools. You can have multiple applications on each user pool that uses the same users, and if you have different user pools, those are totally different users. You can run federated identity on any pool or what have you. It's quite easy to set up, and it has lots and lots of options. How much time do I have left? Ooh, the runtime took longer than expected. It always takes longer than expected. So, I will try to show what Cognito is. Anybody here seen Cognito? A few guys. Anybody here saw the new management console? And the old management console? Yeah, the old management console was ugly. The new one it's better. It looks like it was made in 2015, not 1885. So, as always with Amazon, this looks like this, and we have our user pool here. It has no users. I intended to have a demo about this, but didn't manage to. So we have all our users here, and we can filter them out by all the predefined properties, and we can add identity providers that will allow users to basically log in with Facebook, Google, basically at the click of a button. We can add validated domains, we can add a lot of things, we can add specific applications. We have our client application here that says, how will this application used? Will we allow the user and password authentication? Will we enforce SRP protocol? Will we use FFresh tokens? How much the tokens are lasting? This is for demo purposes. Access token on one day is allowable only on the developer machine. Even in staging, it should be at least something like half an hour. You only set it to 1 day if you hate the QA, because they need to test the refresh token flows and things like that, and you say, well, you change it, and then you wait a day. I cannot change it here. Of course I can, but maybe I don't want to. And the best part, when I'm able to find it, is the custom properties. So that's what I wanted to say a bit. I will rush through that part when I get to it. The good parts of Cognito, in comparison with most other, as I said, most other authentication providers offer something that is extremely similar. Nobody is jumping out here. Depends on the ease of use, on support, on how well it integrates with other services from that cloud provider and whatnot. But whatever it is, I'm using Cognito at the moment, so that's what I can talk about. So the good thing is that we can have custom attributes. Because, for example, we wanted to have a job position attribute on our users, and that's not in the predefined set, so we just added it. And then we added some extra claims, extra things. We added the last login property, for example. We added what we needed, so we made it our own. It uses Json Web Tokens by default, and that's great, as I said. I love Json Web Tokens. It has a great API to use it, whether we are using it through AWS Amplify or directly. The API, well, it's an Amazon API, so it's just as good or bad as all of the Amazon APIs, but it's really nicely made in my sense. It enables you to do what you want to do quite easily. Unless it doesn't work, then you're on your own. It has a great CLI support, because AWS CLI is just good, unlike some others. And we can add enough hooks, that's lambdas actually, or functions in Azure. We can add enough hooks to several places in the authentication flow or the user creation flow or whatever flow we want to do, so that we can have ready-made analytics that are invisible, so to say, to the user, that happen behind the scenes. So for that kind of things, it's really good. What's bad about Cognito is that for reasons unknown to anybody, including Amazon, lots of options are create only. So you can create them, but you cannot change them, you cannot delete them. So for example, if you add a custom attribute and you misspell the name, your best bet is to destroy that pool and start over. Why? Literally nobody knows. I asked almost everybody, but they say it is like that. Custom attributes are great, but if we want to sort on custom attributes, that is not supported by default. And that is actually a huge problem. Because if you have something like 10,000 users, and you want to sort by job position, that means that you will have actually to load all the users yourself on the client side, and then sort them on the client side. And that can be less than optimal. We cannot really customize what's inside the tokens or not. So for example, if we have a custom attribute, that custom attribute will be included in the token, whether we want it or not. So we cannot have a hidden custom attribute. And what annoys me, it's missing support for some password flows from some user authentication flows. Most commonly, the refresh token rotation flow is not fully supported on Cognito as of now. It might be tomorrow, I don't know about that. So these are the bad things, and these are the just plain ugly ones. The old console UI was something that was done by some Amazon intern in 2008, or something like that. And it was the worst UI I've seen, including those I've built. And I once had a client says, this looks like it was designed by an engineer. Yeah, so it was very ugly. And one thing, any DevOps guys here? Yeah, some. They are actually using auto-generated resource IDs. So you cannot set the name of the resource ID. Amazon will generate it for you. And if you need to use that resource ID in other scripts, Terraform scripts and such, you need to do a bit of back and forth until you get it. So it's a bit of a nightmarish task for Terraform. Writing a thing that automated SQSs, for example, took something like an hour. Writing a thing that automated Cognito pool creation took a week. The preset UI, because we are also given a preset UI with Cognito, is something that nobody has ever used. Because it's ugly, it's non-functional, it's kind of customizable, but not really. And Cognito still, weirdly, still doesn't have support for the magic link flow, where it just sends you a link, you click it, and you're logged in. Why? Because they say they'll get to it. And just a little bit about the thing I showed you, kinda, is what I am actually using. So for password and profile management, I'm using Cognito. I have a special backend service that actually does the administration, that actually talks to Cognito. The front end does not talk to Cognito. The front end does not know that Cognito exists. The front end knows the backend service, and the backend service has access to Cognito. That's all there is. And as I said, because we want ease of access, like sorting on custom properties, we are using Redis to aggressively cache the data. So, and we use that Redis cache also for the verification process, so we can have both performance and security. We managed not to make a trade-off between performance and security. As we saw right now, we have fast verification that is also correct. It's quite easy to have an extremely fast verification that is occasionally incorrect. We are using simple email service for Amazon for sending out forgot password emails, welcome emails, things like that. That's a great, the name says it all. It's a simple email service. It does its job. And as for authorization, if I start talking on that, we're going to be here in a week. So I'm going to end it here. After that, after we authenticate the user, we authorize it. How? Correctly. So that was about it. Thank you. Any questions, any comments? Don't be afraid to reach out on Twitter or wherever. Still don't have OnlyFans, sorry. Yeah, if I managed to sufficiently confuse all of you, thank you.